At the end of the last video, I was quite ambitious about what I was going to be able to accomplish and immediately started thinking about exactly the steps that I would need to take in order to get there. One of the first things I did was I took these connections out of this blue breadboard and making more use of a larger breadboard, I figured I'd go ahead and drop them in here. And I printed up, well, and correctly printed up a label so that I had everything labeled and I knew what was going to what. And then I started thinking about the chips I would need to place, and that's where I ran into problems. It is not scalable as it sits now. To take a look at what I would need to drop in a new EEPROM and then a couple of demultiplexers in order to handle those signals. And then I would started thinking about it, and I needed to latch the output of that EEPROM to take away the latency. And then I would probably need a couple of more demultiplexers in order to handle some other signals. Wasn't quite sure about that yet, but I had a pretty good feeling I was going to need those. And I could add another board up here on top for some of this, but it just isn't going to scale right. And as I get farther and farther into this and need more and more control signals, initially out of EEPROM, it's going to end up being a bigger mess than it really needs to be. So first things first, let me revamp this in order to make things more scalable. Let's get right into it. There's a lot to do. Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey. Okay, so the first thing I want to start with here is, other than pulling out the loose ICs here, I actually want to take these two breadboards off the build. And I want to separate the instruction register so that it stands on its own. The challenge is that the break is here, so that means that all of anything that crosses this, effectively this red line here, has to be repositioned and handled differently. So let me work on getting that done first. And that's going to be a little bit of, it's going to be a little bit of effort to get that done. So let me work on that here. Okay, so that then extracts this little board. So I'm going to go ahead and clean up and start working on pulling this back together. I need to move some stuff out of the way. Okay, so the goal here is now to replace these two boards with these four boards. And I believe the strategy I'm going to take here is, this is what is managing my clock signal. This is an XOR gate, 74LS86. I'm going to put that down here on this bottom board and leave the rest of it blank. I'm not exactly certain what I'm going to put in there yet, but I'm sure I'm going to use that as an extension of my interfacing or something. And then I'm going to take my control EEPROM and drop it in here towards the left. And then this is my latch for the outputs. I'll put that right next to it. And then anything I need to manage those signals on the way out of the board, I'm going to stick here. And what that should allow me to do is gradually work my way up as I need the second, which I'll need quickly, and then the third, which I'll probably need pretty shortly after that. EEPROM, along with anything I need in order to manage those signals. And if I need to, for example, expand something out horizontally this way to continue to manage the signals coming off of the EEPROM, I'll go ahead and tack a board over here on the side and use that to continue that on out. So I'm anticipating no more than 2 wide and probably 6 or 8 tall as I get into this. But the key now is to move, well, let me get power and ground routed up here on this. And then the key is to start moving these bits down here to these 4 boards. While I'm working on this, I just want to remind everybody that I don't pre-plan everything so that I have the greatest chance of success on video. Instead, a lot of what I'm doing for the first time as I'm recording it. Missing the layout of the control logic is an example of that. I made no effort to try to pre-plan that all the way through. I threw a bunch of components on a breadboard and started building it out, and then only when I went to do this video did I realize just how poorly my planning had been. And the reality of the situation is you're likely going to see me redo several things. I promised an in-depth look at what it takes to go through this, and you're going to get the good and the bad and the ugly associated with it. All right, well, that addresses power and ground and decoupling, and I am cleaning these up and dropping them in my little pre-cut wire bin here because I will cut those down for smaller connections. Now, the next thing I wanted to do was I wanted to bring the clock input and its signals down here. Yeah, control 2. So I'm just trying to think this through a little bit here. Probably not very successfully. Control 2 would be there, and its latch chip would be here. The key with the latch chip is going to be that the clock needs to come from here, and then will need to be carried up. Now I'm thinking about doing something that I did in my previous build, which was dedicate a couple of columns here for the clock and inverted clock. And what that allowed me to do ultimately was tie just back here to the end of the board. And I think that ends up being a relatively good idea. So let's dedicate this outside column here as the clock, and then we'll do the next row in as the inverted clock. Let me get the ground and power for the control. And what I'm pondering here is about how I want to go about hooking up the address lines. Do I want to drag them out and around, which creates a pile of wires, which frankly is quite messy and difficult to keep straight? Do I want to put a ribbon cable in here, which is going to end up making things challenging from getting the IC in and out perspective? Not to mention the fact that they kind of have to leapfrog each other. So if I've got the low side here and the high side here, the low side has to come over the high side, and this has to come over that, which has to come over that, which has to come over that. It becomes an unwieldy mess very quickly. Or do I create a printed circuit board for pulling those, not a printed circuit board, but a strip board for pulling those in? And I'm kind of liking that idea at the moment. All right, I've got a clean spot up here. So now I got to clean this up because I can't have that. Let me get into that. Yeah, that looks nice. I could get used to that kind of OCD. The other thing I want to do is I want to take and go ahead and expand this up and stick one more control, and I'm just double checking it, one more latch, just so that I have everything taken care of for up to 24 control lines. So basically it's going to be a little bit more of the same. Let me just go ahead and get power and ground and all of that stuff in here and get these ICs labeled. Okay, that then takes care of all of the outputs off of the EEPROMs into the latch. And so now I have to deal with what signals are going to go where. For example, down here, I think I want to put in the address bus 1 assert. Well, I take that back. I probably want to put in the main bus assert down here and use this section in order to decode that main bus assert based on what comes off the lowest 4 bits. So let me clarify that. So the lowest 4 bits is going to control what's asserted onto the main bus, but I'm going to have different options that necessarily need to be controlled by here, which will turn on one of any number of 74LS138 ICs. So any number of those. So for me to be able to demonstrate what I'm talking about here, I really need to bring up a spreadsheet that has what I think are going to be my main bus asserts. So let me work on getting that pulled open. Okay, the highlighted section here represents 32 possible things, registers, or devices that could potentially assert onto the main bus. And so in order to determine that, the lowest 4 bits can give me 16. I need to be able to switch back and forth, or I'd be able to identify which of these two sets of things are being asserted onto the main bus. And one of those here is the fetch register, which is really the target of what I'm working on. But what I need to be able to do is I need to be able to identify and be able to push up to 32 different operations onto the main bus. In order to do that, I actually need for the 74LS138s in 2 sets whose inputs come off of the instruction register, but which of these 2 sets is actually controlled by signals. I'm pointing at the EEPROM, but it's really the signals coming out of here, such that I can activate one or the other of these 2. I need to get things labeled up. I need to get a landing point for all of the signals that are going to drive this. And the outputs of these then are going to need to be addressed to go off to each of the different devices. And so what I'm trying to do here is I'm trying to pull bit 7 from the bottom row up to the top row. All right, so now I have, of the 4 bits that come in for selecting which active line there is here, A is the least significant bit. So these get jumped all the way across. B is the next bit up, which is in reverse order here. And we're not going to have nearly enough white, so there's no difference between the two. C is the next bit up. This goes there, that goes there. All right, and then D, which there isn't, the most significant bit here, goes to pin 6, which is active high, then pin 4 or 5, which is active low, and then reverse that over here, pin 6, which is active high, and the next one active low. And then so I've got an active low signal that would be 5 and 5, and then 5 and 5. So these two are actually going to tie up into here, and then I've got to have an active pin 4, which is an active low. This one will be tied low, and then pin 6, which is an active high here, that'll be tied high. And then same thing over here, active low for pin 4, and then active high for pin 6. So these two being the ones that are going to be driven off of here, which are active low signals. So I've got to make sure that I get those coded correctly. Yeah, let me get this all wired up, and then we'll take a look at how we're going to connect all of this stuff. So that now gives me the landing zone 1, 2, 3, 4 bits here to determine which of these is going to actually assert onto the bus. And so the last thing to do here is to take the address bus 1 assert, the and latch signal, and the increment load decrement signal for the program counter, and get those tied into here. I thought about this a little bit, and the AND latch signal is not properly driven by a demultiplexer. And there could be multiple registers that need to latch at the same time as the increment, decrement, and load. So if these are increment, decrement, and load are handled independently, the end latch also needs to be handled independently as well. So that's an easy fix. I just have to make sure that I get the correct delays in there. The address bus 1 assert, hopping back here to my registers, only ones that I can see having to assert their addresses onto the address bus 1, which is the fetch register, are literally, well, let's do it this way, those 4 registers. So I don't need 3 bits. I don't need 5 bits. I only need 2 bits in order to do this. And so with only 2 bits needed, I can save 1 bit here as input into this demultiplexer. I thought I was going to need 5 bits for that. I really only need 2, so that overall saves me quite a few. So I can bundle that into here, and we'll change that up a little bit so that we are handling that a little bit more appropriately. I think we need to get into the code at this point and start figuring out exactly what bits are required where. Okay, so with that, I think I'm going to stop this video here. I am very aware of some of the video links that I've got out there, and I know that this is going to end up being enough content for a second video. So we'll call this part 1. Part 2 will be forthcoming as quickly as I can. This expansion, I'm very happy with this expansion because it actually gives me the ability to set a few things up for success, and it scales a lot better than what I had before. I also got an opportunity to think through a little bit as to what my real needs were versus what my plans were. They really are a little bit different, and I would have been consuming a lot of extra control signals for things that would never get used. So it was good for me to be able to think that through a little bit. The next video is going to include some code, some additional wire ups, and some additional timing analysis. So look forward to that. Thank you. We'll see you soon.